Alright, welcome back to this which we have on the board. This question says, if z is equal to 1 over 2 plus I root 3 over 2, evaluate the conjugate of z all raised to the power 4. So, first of all, I want you to understand that this question is basically under De Moivre's theory, but it does not really have a semblance of De Moivre's theory. So what we're going to do now is, first, this z bar means the conjugate of this complex number in question. The complex number here is this z. Z is equal to this, and now z conjugate, the conjugate of z will be change the sign of the imaginary part. That is, change here from plus to minus. So first, let us take our z conjugate. Therefore, z bar is nothing but 1 over 2. Now minus I root 3 over 2. So this is nothing but the conjugate. Now we are asked to find the whole of this raised to power 4. But before we can find the whole of this now raised to power 4, we need to put this complex number, which is in basic form, we need to put it in polar form before we can apply or before we can use De Moivre's theory to expand. Alright, so to put this now in polar form, we need to first find the modulus of this complex number, which is nothing but r equal to square root of 1 over 2 all square plus root 3 over 2 all square. So if we evaluate the whole of this, we should be able to have 1. Alright, if you evaluate the square root of 1 over 2 all square plus 3 over 2 all square, you should be able to have 1. Alright, you can try it out with your calculator. Now, next thing now to get here is to get the argument, because the two important things to get, alright, for we to be able to put a complex number in the polar form is number 1, the modulus, number 2, the argument. Now we've gotten the modulus to be 1. What about the argument? So for us to get the argument, we need to draw the argan, we need to kind of sketch the argan diagram, of which the vertical axis represents the imaginary axis and the horizontal axis represents the real axis. Now looking at these two complex numbers, now this is the real part, we're going to put the real part on the real axis, and on this real axis, which is the x-axis, this is 1 over 2. So 1 over 2 is positive, so we're going to put it on the positive real axis. Now this is minus root 3 over 2I, of course, and this is the imaginary part, and because it has negative, we're going to put it on the negative real part. So this is going to be root 3 over 2. So let's put this one up here, 1 over 2. So the line, the diagonal is going to be here. Now it means that, so therefore it means that the argument theta is going to be the angle taken from the positive x-axis anti-clockwise until it touches the diagonal. So the whole of this angle now is our theta. I hope you understand that. Alright, remember, please, you can go back to our previous videos we made. We see that argument is that angle taken from the positive x-axis anti-clockwise until it touches the diagonal. I hope you can see that clearly. Okay, so this is our argument. Now, what we're going to do now is to find the angle here. Alright, okay, so but there's an angle here. We can call this angle alpha. Of course, this line, this part is also root 3 over 2. Very important. And here now is 1 over 2. So we can use this side and this side to find this angle alpha. And of course, if we can find angle alpha, we are going to say 360 minus alpha will give us our angle theta, which is the argument. So if you apply angle formula, tan, you can see that tan alpha is equal to opposite over adjacent, of which root 3 over 2 is the opposite and 1 over 2 is the adjacent. So tan alpha here is nothing but is equal to opposite over adjacent, which is nothing but root 3 over 2, which is the opposite, divided by the adjacent, which is 1 over 2. And of course, this now can as well be written as times 2 over 1. Alright, this is common algebra, 2 over 1, such that this will cancel this. I will now have that. Now, expressing further, I will now have that tan alpha is now equal to root 3. Therefore, alpha now will be equal to tan inverse of root 3. Very important. So if I now do tan inverse of root 3, I should be able to have 60 degrees. Alright, so I will have nothing but 60 degrees. But remember too that this 60 degrees you see here is nothing but this angle alpha. But what we're looking for is the angle theta. And it is this angle theta that is actually our argument. Alright, therefore, if we now say Therefore theta, let me just put it up here. Therefore theta is 360 minus alpha. Therefore theta is equal to 360 minus 60, which is nothing but 300 degrees. So 300 degrees is actually our angle theta. So don't forget our modulus is 1 and our argument is 300 degrees. Now having gotten that, we can now put this complex number now into polar form. Therefore the polar form of this complex number z bar is equal to 1 into cos 300 degrees plus I sine 300 degrees. Okay, let me just clean up. Please do well to take down this load, very important. Okay, now don't forget that we are, if this is equal to this, if z is equal to this, evaluate z bar all raised to power 4. Now z bar is something as this. Alright, z bar is this, of which when we put this z bar in the polar form, it is now this. Now, from this part now, we can answer that z bar, which is, now of course this is 1 multiply all of these things, still give, okay, let me just still keep it the way it is. So we can say that this, therefore, okay, z bar raised to power 4 will now be equal to 1 into cos 300 degrees plus I sine 300 degrees all raised to power 4. Now at this point, now this is where I'm going to apply De Moivre's theory. Now what De Moivre's theory states is that whenever you have a complex number in polar form and it is all raised to power a particular number, alright, that the number, which is an integer, a positive integer of course, will raise to this modulus, and that same number will multiply the arguments. Alright, therefore z bar all raised to power 4 is equal to 1 raised to power 4 into cos 300 times 4 plus I sine 300 times 4. So we have this. Now evaluating this in further now, you now find that 300 times 4 gives us 1002, and 1 raised to power 4 is nothing but 1. So 1 into cos, into cos 1200 plus I sine 1200. We have this. Now at this stage now we can evaluate cos 1002 and sine 1002. So when we do the evaluation, we have that cos 1002 is nothing but minus half. This is equal to 1 into minus 1 over 2 plus root 3 over 2r. Because sine 1002, if you evaluate it with your calculator, sine 1002 gives you root 3 over 2. Now, this is 1 out here, so if this one multiplies this, it's still this. So, using this one now to open out the bracket, you find that it is equal to, that is z raised to power, z bar raised to power 4 is equal to minus 1 over 2 plus root 3 over 2r. And that is the answer. Alright, so please do well to take down the notes.